Welcome back, grade 11s, to writing balanced redox reactions without using the table of reduction potentials. We are going to, in this video, discuss another example where the reaction takes place in acidic medium. So the first thing that we need to do is to separate the reduction half reaction from the oxidation half reaction, and we do that by identifying the oxidizing agent and the reducing agent. We use oxidation numbers in order to do this. So we start with the permanganate ion. The oxygen's oxidation number is -2. There are 4 oxygens contributing to the total negative charge of -8, and of the -8, 1 is kept for the negative charge on the permanganate ion. So the positive oxidation number of manganese is +7. Hydrogen is +1, sulfur is -2. The manganese on the product side is +2 because its ionic charge is 2+, and the sulfur is by itself, so it's got a 0 oxidation number. The next thing is to see whose oxidation numbers changed. Manganese changed from +7 to +2. That's a decrease in oxidation number, so that would be my reduction half reaction. And the sulfur in the hydrogen sulfide increased from -2 to 0, so that would be the oxidation half reaction. So our oxidation half reaction starts with H2S and it forms sulfur. The reduction half reaction starts with the permanganate ion and it ends off with the manganese 2+ ion. So we have to follow the rules. We balance the number of oxygens by adding water. So on this side here we have 4 oxygens, so we need to add 4 water molecules on the product side. The next step is to balance the hydrogens. So we've got 2 hydrogens on the reactant side of the oxidation half reaction, so we balance that by adding 2 hydrogen ions on the product side. And with the reduction half reaction, we have 8 hydrogens on the product side, so we need to add 8 hydrogen ions on the reactant side. Then the next step is to balance the number of elements that are not hydrogen, not oxygen. So the sulfur on the oxidation half reaction, that is balanced already, and the manganese is balanced in the reduction half reaction. The next step is to balance the charge. So the total charge on the oxidation half reaction's reactant side is 0, and the charge on the product side is +2 from the hydrogens. So we need to get it to 0 by adding 2 negative electrons. In the reduction half reaction, we've got a -1 charge from the permanganate and a +8 charge from the hydrogens, that gives us a +7 charge. On the product side, we've got a +2 charge. So we need to cancel 5 of these pluses on the reactant side. So we add 5 electrons. Next is to balance the number of electrons that are given off. During oxidation, you've got 2 electrons given off. During reduction, you've got 5 electrons taken in. The lowest common multiple is 10. So this oxidation half reaction we need to multiply by 5, and the reduction half reaction we need to multiply by 2. So 5 hydrogen sulfides will give us 5 sulfurs, 10 hydrogens, and 10 electrons. The reduction half reaction says 2 permanganates will need 16 hydrogens and 10 electrons, and it will give us 2 manganese 2+ and 8 waters. In this reaction, we notice that there are 10 hydrogen ions on the product side of oxidation and 16 hydrogen ions on the reactant side of reduction half reaction. So we can cancel those out as far as possible. So in the net reaction equation, we have 5 hydrogen sulfides, 2 permanganate ions, and then 6 hydrogen ions. The electrons cancel. That gives us 5 sulfurs, 2 manganese 2+ ions, and 8 water molecules. So this is the balanced net equation without any spectator ions, and the steps we go through if we're not allowed to use or we can't use the table of reduction potentials. Thank you for watching the video.